Our keynote speaker is Mr. Bill Wuertz, Vice President, Cloud Systems, Seagate Technology. Just a brief introduction before I welcome him onto the stage. Bill Wuertz is Vice President of Engineering for Seagate Cloud Systems. He is responsible for all storage systems product development under the Seagate Cloud Systems Group. Prior to joining Seagate, Bill served as Dot Hill's Vice President of Products and Solutions until the company's acquisition by Seagate Technology in October 2015. Early career highlights include Senior Vice President and General Manager roles at LSI Corporation and at Symbiosis Logic. Among Mr. Bill's many accomplishments, he has secured patents in the areas of electronic security and was awarded the AT&T Best New Patentable Invention in 1994. Ladies and gentlemen, please extend a very warm welcome to Mr. Bill Wuertz.
So, Mr. Ruthi from Intel talked about data growth, data acceleration, and that was a great setup for me because I'm going to talk about where data lives and why that might not be good for you. So that's my teaser. I hope you enjoy the talk, and we'll get started. So, but before we get started on the big shift in data and why that might not be good for you, I want to talk a little bit about cloud systems in India. You know, we're a global overall organization within the Seagate umbrella, and we've tapped into this deep well of storage expertise here in India. Over 750 engineers right here, system design, silicon design, software. I'm proud to say that our India team right here innovated from scratch, our latest, newest system, developed it, prototyped it, built it right here in India, and we've shipped it worldwide to key customers. So very excited about our accomplishments here in India. I've been coming here for about 15 years, developing new products and systems, and have had a great result. In fact, my strategy here in India is 50-50. So 50% of my staff is here in India, has been for quite a while, and then the other 50% of my staff is around the globe, and has been very successful for me. So I wanted to start with that. Jason talked about my background a little bit. I promise you, I am not a minister. I'm not a politician. Anything I learn about politics, my wife tells me, and so I'm an engineer. So maybe not the best speaker, but I think I can talk a little bit about the technology. The big shift. Again, this is about where data lives and where it's going, and how to take advantage of that. It may not be good for you, and that's the problem. Let me talk a little bit about a couple of examples. For example, Target Corporation, the competitor to Walmart, was one of the first innovators in targeting ads at people. And so, not so long ago, a father with a 19-year-old daughter called Target Data Center and said, "Hey, what the heck? You're targeting my daughter with ads on, baby powder, baby bottles, baby blankets, things like strollers, all this baby stuff. Hey, I'm the father, and I don't like that because my daughter, isn't married. She's too young. Why are you doing this? Seems like a mistake." And so the Walmart data center guy said, "Well, I don't know. We have algorithms. I don't know what's going on here." So 2 weeks go by, and the father calls back to the data center and says, "I apologize. My daughter is pregnant." And the data center guy said, "You know what? In the last 2 weeks, I did a little analysis, and I found that the machine had learned. The machine had learned that if young ladies, say 19, 20, 21, buy a certain kind of hand lotion, buy a certain kind of painkiller at a certain rate, click on certain websites, the likelihood that these individuals are pregnant is extremely high." So think about that. The machine learned all this and so the machine knew that this young lady was pregnant even before the father knew. It's kind of amazing, what's going on here. And I'll give you another example near and dear to my heart. I'm a pilot as a hobby. I've been flying for decades. And 20 years ago, I used to fly right through the Denver airspace, over the Denver airport, and all they had is radar, raw radar. They shoot it at your plane, they look at the screen, they have the green screen with the little dots, and it's very imprecise, and even the air traffic controllers would admit that, and they have to keep the planes apart by 5 miles, because it's not very precise. And so a couple weeks ago, I was zooming through the Denver airspace with my family in the plane, I have a flat screen in my plane, a little diamond pops up, little white diamond with a vector, and it has some information. And the information said it was a citation jet coming out of 17,000 feet, and the vector was a collision course, in 20 miles with my plane, and sure enough, 15 seconds later, the air traffic controller comes on, and he tells me there's a target. Target is coming out of 17,000 feet. He's going to land in Denver, and you need to watch out for him. And so if you pause right there and think about the machine-to-machine data sharing of today's world, my GPS data, my heading reference, digital heading reference, my altitude, my trend, all that information went via a 1 gigahertz signal up to the citation jet. He sent me his information, all automatically, machine to machine. And then, by the way, that information all went up to the satellite and down to the FAA data center, and so that the air traffic controller, so all three of us knew exactly what was going on. So in the olden days, they'd have to give us all kind of vectors and trouble, basically. And today's world, everybody knew exactly what was going on. And the fact that we were going to come kind of close, but that we had it under control and everybody knew, and it looked like the citation jet was going to go. This is a true story. And so with, about 10 seconds before this target came by, the screens in the citation jet in my plane popped up and grayed out all the navigation, just showed the targets and the vectors and the information, and then came out with an oral warning, caution, potential target. So the machine learning, the machine information, made it all work out. So 5 seconds before, potential collision, I look up, the citation jet's coming out of the cloud, and sure enough, he's going to go right behind me. So it's just another example of what you can do with data, and there's a tremendous amount of data from all the airliners, millions of planes, going up to the satellite, down into the data center, and that data has to be stored for a while because of potential, legal actions or reasons for that information. So machine-to-machine learning is, and it's not just travel safety, it's not just OLTP, online transaction processing, it's surveillance, as you know, it's media and entertainment, it's government, legal, financial, it's every sector. It's very exciting for us that are in the storage field. So, the big shift, let's talk about that a little bit more. So, the location of data is shifting to the cloud. That's probably not new news to many of you, but when something is changing, what do? You measure it. And actually, who is better to measure it than Seagate? We supply the drives, and we track this stuff with amazing precision. So in 2010, nearly 2/3 of the data was stored on PCs. In 2020, 10 years later, the data is 10 times or bigger, and 2/3 of it is actually stored in the non-PC environment. So that's a big shift in where this data is going to be. And so that's kind of the setup. And if you look, don't worry about the details of the data. I just kind of want to make the point that if you look at it, the first bar there is OEM external, so external storage. Think about Dell EMC, maybe HP, all the people, NetApp, people that make external storage. And then the middle bar there is storage that's attached or within a server. And then on the right-hand side is ODMs, just raw systems that are purchased with no software and those kinds of things. And this is not good news for some of us. This is the not so, the big data shift. If you're Dell, Dell EMC, HP, Lenovo, or you supply products into there, which is many of us, you can see the size of the overall data there is still this enterprise infrastructure is the biggest piece. There's a lot of people working in the cloud. If you work in the cloud, man, it's great. You're a rocket up to the moon, and it's great. But if you're the vast majority of the rest of us, this is not necessarily good news. So, you're on the way down. But if we look at it just a little more clearly, and one more slide. Chris Miller from the Register turns up the contrast a little bit, and he said that great giant sucking sound is all your data going into the cloud, right? And if you look at it, and you may not be able to see the details on the numbers, but back in 2010, these big 6 cloud guys were only about $5 billion in terms of CapEx, how much of the systems that they buy or make. And in 2016, just 6 years later, It's $30 billion. The growth has really outstripped what any of us thought it would be. So, you know, the cloud is clearly sucking up a lot of the data. So what does that mean to us? Well, here's a hint on, you know, how we can think about this a little bit and work in this environment. Don't worry too much about the details, but the bottom part of the bar there, if you look at it, is public cloud. So that's these 6 or 7 or 8 or 10 big cloud players. And that's fine. There's a lot of the storage that's ending up there. But if you look at the other 2 pieces to the bar on top, that's the private cloud, either on-premise or off-premise. And that data is actually a bigger piece and growing. So those of us that, you know, ship and build and innovate in the storage area may think about, you know, targeting, you know, private cloud. That's, you know, folks like perhaps filmmakers that, you know, for security reasons perhaps don't want their information on the public cloud, maybe financial institutions, certain folks like that. So as we look at storage, you know, the nature of the data is changing, and a lot of it is going to the cloud. But that, depending on how you target your products and things, it's not necessarily a bad thing. So what can Seagate do to help? What is Seagate doing? What are we focused on to help this? And again, it's a bit of a complicated chart, but you know, today's world, you've got 10 terabyte disk drives, 12 terabyte, 14 terabyte disk drives, 16, but that's all perpendicular magnetic recording, and that has run out of gas. You just can't pack it any tighter than that. And what's really needed by the industry with all these applications and machine learning that we talked about is to an inflection that actually increases at about 30% compound annual growth rate. So the good news is Seagate has been innovating in the area of what we call HAMR, or heat-assisted magnetic recording. And I'll talk just a little bit about that. The grains of magnetic material have to get smaller and smaller and smaller. But the smaller they are, the more likely they are to flip and to be unreliable and to go away. So you have to bring up the coercivity. In other words, the ability to flip that bit, you have to bring it up higher and higher and higher so that the reliability is maintained even with the smaller bits. But the higher the coercivity, the harder it is to write that stuff. So Seagate has innovated, as you can see, a heat-assisted element. And in the sort of the middle of the bottom there, you can't see it too well, but the plasmons of light actually sit more so on the outside of the light pipe that is the laser. And Seagate figured out, along with partners, that if you quickly neck that down, it highly concentrates the plasmons of light, and it gives a tremendous focus and a tremendous heat. So as the media, the platter of the disk is spinning around, it's heated instantaneously. You flip the bit, and then you let it go, let it cool down, and the bit is locked in place. It's called HAMR, or heat-assisted magnetic recording, and we're very excited about it because it's going to change the ability to store data at a much higher level. And this is just another chart that talks about that a little bit. As you look at it, we've demonstrated 2 terabits per square inch. That's a tremendous amount of data in a very small space. So again, we're highly focused on where the data lives and how to help the folks that are going to make money off this and you know, have business based around this data, help them move forward. And another thing to think about is the big cloud players invest a tremendous amount in software, features and functions to store data from people that share data up in the public cloud. The rest of the companies may not have that same infrastructure, so to compete, you could think about changing the game a little bit. So for example, from Seagate today, the next generation drives are going to be in that 14 terabyte frame, and it's a regular disk drive about this big. You could think about, you know, Seagate, we're looking to offer something 100 times as big, 1.4 petabytes. So on the left-hand side, you know, you've got 10 platters spinning. On the right-hand side, you've got 1,000 platters spinning. So 100 times more. And also that 1.4 petabyte drive is going to be much higher reliable, much less cost per gigabyte, and you know, 5-year no touch. You buy it, it's self-healing. And how are we going to do that? So as we look at it, there is no magic. You're not going to be able to pack 1.4 petabytes in something this big today. Maybe someday. But as you can see on the left, this is what the cloud guys, both private and public, do today. They take boxes in that sort of 88 disk drive range. These things weigh, by the way, 215 to 300 pounds. But it's a giant disk drive, depending on how you outfit that with software. And so it has all the standard things. What we're working on at Seagate, and we've actually shipped to first customers, is an intelligent, what we call an intelligent drive. So with an amount of processing intelligence, a small amount of processing intelligence, we can offer these things with more disk drives, far superior, self-healing technology. So when one of those platters goes bad, instead of failing the whole disk and rebuilding the whole disk, we can actually rebuild without that platter. And so just a minor amount of lower capacity, but we make that up in other ways of intelligence. And Seagate is ideally positioned here because we own both ends of the wire. The disk drive end, where the disk drive lives in the firmware, and the cooperation and the communication up with the system of the drive. So I'll talk just a little bit about this, and then I'll start to wrap up. But when you own both ends of the wire, there's some very interesting things you can do to help enable this. For example, say a 10 terabyte drive. In today's systems, all the drives in there have to be 10 terabytes to set up all the RAID activity, the reliability software and firmware. But with Seagate, since we own both ends of the wire, when you make these disk drives, they don't all magically have 10 terabytes. They have 10.1 or 10.2. You have to yield them, right? 10.4, 10.5 terabytes. What do we do with all that extra space? It's a tremendous amount. It's probably 5% or more of extra space on that drive. What do we do with it? We throw it away. And so, the idea is if you own both ends of the wire and you have the right software, you can actually take advantage of that and offer more to our customers for the same price. So that's something we're working on. Another is these number of tracks per inch have gotten so small that just the fans alone vibrate the disks just enough through acoustic coupling to throw off the track and cause the performance to go way down. So there's some things in Seagate systems where we can actually take some of the less sensitive drives and put them right by the row of fans, and then the more sensitive drives and get more capacity through the rest of the box. Another thing is certification time. Think about disk drives today. How long does it take to test them? 5 minutes? 5 hours? No. These 14 terabytes, you're talking weeks to test them because you have to find all the bad bits and map those out, right? Well, guess what? If we make the system, we can do those as we store the data, and we don't have 3 weeks in the process we don't need to do, and that's a tremendous cost savings for the overall system and for our customers. And there's a bunch of these, and I won't go into them all, but these are the kinds of things we're working on at Seagate to enable this data center of the future. So I'll wrap up there. The enterprise disruption, data shifting, the cloud is growing wildly. I would consider offering storage at a whole new level, and Seagate's here to enable that part of the industry. And then the last thing, as I said, storage innovation here in India. It's critical to Seagate right now. Thanks for your time.
I'd like to request Mr. Ram Reddy to present a small token of our appreciation to Mr. Bill Wuertz. Ram, if you're in the house, yes.